So now we're going to define, we're going to look at plane geometry. We're actually looking at the geometry of two-dimensional objects. So we're going to be looking at things like circles and polygons, and those are quite exciting. So let's start off with talking about polygons. Polygons are two-dimensional objects. It's good to know the root words. Poly means many, gon means angle. So these are pictures of polygons, and these are pictures of two-dimensional objects that are not polygons. The difference between the photos on the first page versus the second one, you can see that in the first one we have lots of straight lines. Second one we have circles, we have curves. The first one we have closed spaces, whereas in the second one we have straight lines and angles, but some of the objects are not closed, or they're partially closed. So we define a polygon as a two-dimensional closed shape. They're made of line segments, no curves, and the line segments can intersect only at the endpoints. So if we go back to there, the object on the right, it intersects, it's closed, well partially closed, but it also doesn't intersect at the two endpoints. We have two endpoints that are free. So polygon is a shape of many angles. In order to be made of angles, we have line segments that will connect at the endpoints to form these different angles. Regular polygons are polygons where all the angles are congruent, they have the same measure, and all the line segments are congruent, they also have the same measure. So we have the row that's on top, those are regular polygons, and the row of polygons on the bottom are not regular polygons. Here's some names of polygons. If it has three angles, then we call it a trigon. Actually, we don't. We should call it a trigon, but we call it a triangle. I do not know why, since we never say angle for any of the other objects. We've never heard pentaangle, which has 5 angles, or hexaangle, or octaangle. It's pentagon, hexagon, octagon. Those are two-dimensional shapes that we are familiar with. Those are polygons that we are familiar with. The trigon has 3 angles, or as we learned as a kid, triangle. Pentagon has 5 angles, hexagon 6, octagon 8. Here's a list of some other popular ones. We've got the tetragon, which has 4 angles. We often call it a quadrilateral. Quadra also means 4. Lateral means sides, lengths, so we have 4 sides. Again, we switch from using the word gon, tetragon, and typically use quadrilateral. Nonagon for an object that has 9 angles, decagon, 10 angles, dodecagon, 12. So we're going to define a circle. So let's say we have this point, and I want all of the points that are 3 units away from that point. So this would be a point that's 3 units away. So with that one, so with that one, so with that one, but also so is that one, and that one, and that one, and that one, and then that. So obviously there are an infinite number of points. Oh, this one was that are 3 units away from this point. And obviously I'm not going to be able to draw in every single point, so we cheat and we just draw this curve. We just make this continuous curve, and that represents all of the points that are 3 units away from this point here. So that given point we call the center. The actual circle here is this curve that we see. Everything on this outside is our circle. Those are all of the points that are this many units away from that center. So technically a center is not a part of a circle, but it does help us to define that circle. And the distance away from the center that we were trying to get, that is called the radius. So let's say we wanted to talk about area. So we basically want to know how much of this two-dimensional space, or how much this two-dimensional object is taking up. So usually we like to look in terms of 1 by 1 units. So if I were to look at this rectangle, I would want to know how many 1 by 1 units this rectangle would take up. How much space, two-dimensional space, would it take up? Well, I can see there would be 1, 2, 3, 4, 5, 6, 7, 8 1 by 1s along this direction, and then I have 4 1 by 1s in this direction. So I could say I have 4 rows of 8, or 8 columns of 4. So the bottom line is I would end up with 4 times 8, or 8 times 2, 32 1 by 1 units. So if I were to measure this in centimeters, then this would be 8 centimeters times 4 centimeters, or 32 centimeters squared. So remembering the area of a rectangle is pretty easy. What's often not so easy is remembering the area of a parallelogram. But what's nice about parallelograms is that I can sort of convert them into a rectangle. I could take this part, cut it off, and then move it over here. Because this is exactly the same size as that. And if I move that over there, I still have the same base. And this line right here becomes my height. So this height of this parallelogram is actually the same as the height of my rectangle that I could form taking this over here and moving it here. So the area of a parallelogram is still equal to the base times height. I would take this and I'd multiply it by how high it is. So this perpendicular line, this line that forms a right angle with my base, that becomes called my height, because notice this is the height of my rectangle. This, the length of my base of this parallelogram is, moving my camera, the base, and it's also the base of my rectangle. So the area of the parallelogram is still going to be base times height. If I were to rotate it, then I could call this my base and this would be my height. Bottom line is my height and my bases should always form a perpendicular line. It doesn't matter the orientation, the area is going to be the same. If I want to find the area of any triangle, parallelogram. And if you recall, the area of a parallelogram is base times height. It's the area of the base times height. So if a parallelogram is basically two identical triangles, or if I have a square or a rectangle that consists of two identical triangles, the area of the triangle would just be half the area of the parallelogram, or half the area of the square, half the area of the rectangle. So the area of any triangle is 1/2 the area of the parallelogram, or 1/2 the base times height. The area of a trapezoid is going to be the same thing. If I were to look at a trapezoid and I were to double it, again I would form a parallelogram. So notice the height of my trapezoid is the same as the height of my parallelogram. And now notice that the base of my parallelogram is now the length of the bottom of the trapezoid plus the length of the top of the trapezoid. Or you could do the length of the top and the length of the bottom. The whole point is that my parallelogram, the length of my base is the sum of the two bases of my trapezoid. So if I wanted to find the area of the trapezoid, I'd have to add the two bases together, multiply it by the height, because that's the area of the parallelogram, and then I divide it in half. And because I only need half of that parallelogram, because half of that parallelogram is my trapezoid.